We will solve exercise number 2. In exercise number 2, air is to be compressed in a single stage reciprocating compressor from 1.013 bar and 15 degrees to 7 bar. Calculate the indicated power required for free air delivery of 0.3 meter cube per minute when the compressor process is as follows. So we are asked to find the temperature to T2 and indicated power for the three processes: isentropic process, reversible isothermal, and polytropic process. He is asking us to find the delivery temperature in each stage. So the first process is isentropic process. Before we proceed, we will find mass flow rate. Mass flow rate can be easily found by PV over RT. In the problem, he has given you pressure 1, volumetric flow rate, and he has given us the temperature. So I am going to substitute pressure 1.013 multiply by 10 power 5 because I will take the value for R in joule. So volumetric efficiency, volumetric flow rate is 0.3 divided by R value 287, not 287, it is in joule, multiply by temperature 273 plus 50 degrees. I am changing it into Kelvin. So mass flow rate, I will get 0.368 kilogram per minute. Now, how to find the temperature T2 in isentropic process? T2 over T1 equal to P2 over P1 power gamma minus 1 over gamma. So T2 will be equal to 288 multiply by 7 divided by 1.013 to the power of 1.4 over 1.4, 0.4 over 1.4. This will give you temperature T2 500.3 Kelvin. Now for this process, the isentropic power is given as gamma over gamma minus 1 m dot R T2 minus T1. I will substitute the values. Gamma is for air is 1.4 divided by 0.4. Mass flow rate is 0.368. R value is given as 287 multiply by temperature T2 is 500.3 minus 15 degrees. You change into Kelvin to 88. Now the mass flow rate is in kilogram per minute, so I am going to divide this by 60 to make it into kilogram per second, and the R value I am going to make it into kilo, that's why I will divide by 1000. So what I am doing is I am changing the mass flow rate into kilogram per second, and R value I am changing into kilojoule. So if you solve this, you will get the answer as 1.31 kilowatt. This is the indicated power if the process is isentropic. For reversible isothermal, temperature remains constant. So T2 equal to T1, that is equal to 288 kilo Kelvin. 288 Kelvin. Now let us see how to find the indicated power. Indicated power can be found by MRT ln P2 by P1. So I will take mass flow rate to get answer in kilowatt because we are looking to find the power. So again, mass flow rate is 0.368. I am going to divide by 60 to make it kilogram per second. R value is 287 divide by 1000 will give you in kilojoule per kilogram Kelvin, multiply by temperature 1 288 ln 7 divided by 1.013. So if you solve this, you will get 0.98 Kelvin. So we have got for two processes. Let us do the for the last process. It is a polytropic and n is given as 1.25. So T2 by T1 equal to P2 by P1 n minus 1 over n. And I'm going to substitute and get the value for T2, which will be equal to 2887 divided by 1.013. So 1.25 minus 1 divided by 1.25. So you get the temperature T2 423.9 Kelvin. And the indicated power, I'm going to use the formula n over n minus 1 m dot r T2 minus T1. N value is given as 1.25 divided by 1.25 minus 1. Mass flow rate 0.368 divided by 60 to make it into kilogram per second, and R value I am going to change it into kilojoule. So I will divide this by 1000 and T2 minus T1. T2 is 423.7 minus 288. If you solve this, you will get IP 1.2 kilowatt. So we have solved the temperatures and indicated power for the three processes which are given here.